Good morning and welcome to this session 16 from the playlist of friction. The topic is the angle of friction and the angle of repose. So based on this topic, I have written here two important points pertaining to the angle of friction and the angle of repose. And these are the two diagrams which are in relation to the angle of friction and the angle of repose. So this is the diagram number 1 and this is the diagram number 2. Now first of all we will discuss about the angle of friction, and the diagram number 1 pertains to this topic. So angle of friction is basically the angle which the resultant of the limiting friction and the normal reaction makes with the normal reaction. So this is a body which is lying on a rough horizontal surface and it is subjected to a force F in the direction as indicated by this arrow, and here FL is the limiting friction. Limiting friction is the maximum value of the static friction. So when I will apply a force in the direction as indicated by this arrow, then the limiting friction will be acting in the opposite direction as indicated by this arrow, and here the limiting friction is depicted as FL, and here N is a normal reaction. So the resultant of the this limiting friction and the normal reaction is R, and the angle made by this resultant with the normal is called the angle of friction. So the tangent of this angle, that is tan theta, is equal to the coefficient of static friction. That is, tan theta will be equal to mu s, where mu s is the coefficient of static friction, and here tan theta will be equal to what? This will be equal to FL divided by N. So this is an important relation between the angle of friction, the coefficient of static friction, the limiting friction, and the normal reaction. Now let us come to the point number 2. In the point number 2, I have written down the definition of angle of repose. So the angle of repose, which is depicted as phi, is the least angle of inclination of an inclined plane with the horizontal, such that a given body which is placed over it begins to slide without getting accelerated. So when the angle of inclination is equal to the angle of repose, then in that case this limiting friction, which will be acting in the upward direction as indicated by this arrow, will be equal to mg sin phi. Here phi is the angle of repose and here mg is the weight of this body. So this angle will be equal to phi. So if this angle is phi, then mg cos phi will be this component, and the component parallel to the inclined plane will be equal to mg sin phi. So when the angle of inclination is equal to the angle of repose, then in that condition mg sin phi will be equal to FL. This is the first equation, and mg cos phi will be equal to the normal reaction. So I have already written these two equations here, and by dividing these two equations, that is FL upon N will be equal to tan phi. Now FL upon N from this equation 1 is also equal to tan theta. So I have written this FL upon N is equal to tan phi, and this is equal to tan theta, and tan theta is equal to mu s. So from this relation we can see that the angle of repose is equal to the angle of friction, and the tan of phi, that is the tan of angle of repose, is equal to the tan of angle of friction, and this is equal to the coefficient of static friction, and the coefficient of static friction is also equal to FL upon N. So this is also a very important relation. So thank you very much for joining this session. In the next session, I will be coming up with a question based on this topic, that is the topic of angle of friction and angle of repose. So till then, have a nice day. Bye.